Hello, everyone. I'm Lori DeToro, Senior Communications Manager for Turntide Technologies. Thank you for joining us today for the Current and Wave webinar discussing electric drive units, or EDUs, in power sports and recreation vehicles. We are pleased to have Jason Glass, Greg Snowden, and Nathan Martinez presenting today. They will tell you a little more about themselves in just a minute. Before we get started, we have some housekeeping tips to share. This presentation is being recorded and will be available on demand on the Current and Wave website. We will be taking questions at the end of the presentation, and Jason and Snow and Nate may stop in between some sections to answer questions, so get those questions in now. The Q&A box, not the chat box, to ask your questions, and we will answer them, answer as many as possible. Also, we have shared the link to our March webinar, which will be a tech tour of the new exciting EDU, and that presentation will be live from the manufacturing floor in Gateshead. So take a moment to register for that. And also remember that this is a live event, so when we mess up or do something silly, and we probably will, laugh along with us and enjoy the presentation. And that's it for housekeeping. We're ready to begin. Jason, let's get started.
Thank you very much. Appreciate everybody coming in today, and thanks to Nate and Snow again for helping me with the presentation. My name is Jason Glass. I am the director of Powersports or Motorsports for Turntide Technologies. I've been in the automotive industry for about 25 years or so now, and manage mainly the recreational, marine, and some of our DoD applications here in the U.S. and then a little bit globally as well. So I'll let Snow and Nathan introduce themselves.
Hey, well, my name is Snow. I'm with Current Electric Vehicles, and my background, I started with electricity and electronics in the United States Navy. I worked on weapons. I did that for 8 years, and I moved on to the semiconductor industry. And after I officially retired, I stumbled across electric vehicles and conversions, and the whole thing just snowballed from there. And I was fortunate enough to meet Brian from Current Electric Vehicles, and then essentially Jason, and that's really what got me to the point where we are today.
Awesome. Hey, nice to meet everyone. Nathan Martinez, one of the applications engineers here at Turntide, as well as race director for our race program. So I bring about 8 years of automotive experience. Came from one of the big three, live out here in Detroit. So got to see a lot of different types of vehicles, and specifically electric vehicles, from sedans to heavy duty trucks all the way to last mile delivery trucks. So have a lot of really good experience there, and excited to kind of talk more about what we have to offer here at Turntide.
Awesome. Thank you, guys. So we're super excited today to start talking about and kind of bring you guys up to speed and share some information about the new EDU program here at Turntide. We're going to walk through some of the axial flux motor and inverter technologies that we have here at Turntide. We'll get into the EDU, the basic idea behind it, and the design around that product. We'll look at some of the applications that go into it. We're going to talk a lot about customization of platforms, retrofit, and that sort of thing. And then we'll talk a little bit about Powersports, which, as Nate and I and Snow all get into it, you'll find out we just don't stop talking about it. So hopefully we stay on task. And then we'll talk about some new ideas in the motorsports industry that kind of go along with our EDU, where we're going, and some of the new things that we're super excited to talk to you guys about, and allow you guys to ask some questions throughout the entire presentation. If you have a question that pertains to a slide that I'm working on, please don't hesitate to ask a question, ping one of us. I'd rather it be more conversational than just me reading through slides and the guys, regurgitating information. So super excited to jump right into this stuff. And the history of Turntide is we're kind of a conglomerate of 3 different companies. Most people already know that. We are a manufacturer of axial flux motors, low voltage inverters, high voltage inverters. We do make a 48 volt battery that you can build your own pack out of. We have our own BMS. We have our own pumps. We have our own fans. And all of this is material and products that we manufacture in-house. So we're vertically integrated as a company. So it makes it a lot easier for us to create packages and help you guys with complete systems integration. Axial Flux. I'm going to let Nathan kind of walk through our Axial Flux design, what makes us different, what are some of the advantages that we have in the marketplace when it comes to the turn-tied Axial Flux motor.
Sure thing. Thanks, Jason. So with our Axial Flux motor, this is our high torque density, low weight motor that we offer. We offer it in a couple different sizes. We range from 250 millimeters or 25 centimeters up to 43 centimeters. And so what's unique about Axial Flux specifically compared to radial flux is that if you maintain that diameter and grow a radial flux motor for more power, they grow lengthwise. Whereas with an Axial Flux motor, our depth will remain the same and the diameter itself grows. And when that grows, that's able to induce a greater flux field, which is in turn allowing us to get more torque out of the motor, which has been fantastic. So our latest motor has a couple improvements up on it. We went to an aluminum cast housing, which has allowed us to reduce the overall cost of manufacturing, but as well as the materials and the overall speed to market with that unit, while still maintaining the strength of the previous design. So with that 50% less weight, so we're seeing about 10 kilowatts per kilogram, which is exceptional compared to radial flux motors and even some of our competitors in the Axial Flux motor space. It's been optimized to meet our customer requirements. We've adjusted the mating shaft to be a female spline, and so this allows flexibility to our customers and end users because they normally have something different every single time. So having an inboard one is making it a lot easier for all of us from the integration side. Power ranges we see from about 55 kilowatts, 59 kilowatts up to 375 nominal, and we can get even north of 800 kilowatts of peak power on our largest unit. We operate from 200 to 800 volts, really wide range, gives you a lot of flexibility in how you integrate our product. And then it's scalable as well. I'm sure we're going to talk about it a bit more, but you can stack these motors by 1, 2, 3, and potentially up to 4. This gives us a lot of potential in terms of torque density within a small package. These are going to be, as we'll see kind of later, the sizing in terms of the space claim of these motors is fantastic for the torque density that you're getting. And then one more piece I wanted to talk about was the kind of customization in terms of how the motor is oriented in space. It can be oriented vertical, horizontal, or any combination within space. And then also the top box, which you see there, which has the phase cables in it, can also be rotated and oriented. So there's a lot of customization without really breaking the bank or breaking our manufacturing process for that matter. So that's our flagship motor. This is the one that we're most excited about and that we'll be talking about more, but that's a quick overview for you.
Awesome. Thank you, Nathan. As we kind of progress through, we'll be talking quite a bit about, the stackability of the motor to generate different options as you guys look at implementing the EDU into your systems. So along with that, all of our EDUs are designed to ship with our Gen 5 size 9 and soon Gen 6 size 9 high voltage inverter. This is a 400 volt inverter platform. It's an amazing little unit. We had a great success with it at King of Hammers, where we beat the ever-loving fire out of it. Out there, if you've been to King of Hammers, you know how hard it is on componentry. So Nathan, I kind of let you walk through some of the things, but for me, one of the really exciting things about this platform is how well we can tune it and how well we can customize it for our customers. And really dig into fine tuning it so that it works best with your platform. We do have other versions of inverters that we work with, 800 volt, options as well, but this is kind of our bread and butter. So it's kind of where we like to start. Obviously, every system has different requirements. As you guys start to look at how do I incorporate this EDU into my system, it may require more power, may require less power. There's always going to be options there. We try and stay nimble, but we start with this kind of as our launch platform. So go ahead, Nathan.
Yeah, no problem. Yeah, like Jason said, we really beat up on this unit in the desert, as well as on plenty of dyno time and other obviously customer applications. What's really great about this unit is that the mounting, you can put it really anywhere within your vehicle. It's relatively compact. I don't want to give the wrong sizing, but I mean, it's literally about that big. So maybe the size of a laptop, if you will, and it just provides phenomenal power. It's been consistent for us. To Jason's point of the tuning flexibility, we can really get a lot of amperage out of these units. I mean, right now, I believe we say 400 peak power output for amperage, phase amperage. But we can definitely get above that for a consistent amount of time. That's really just kind of the specification rating. But when you actually put it into the real world, it outperforms what we've kind of limited it to in terms of kind of what we spec it out to be. But with that, there's a lot of different features and parameters that myself and the other application engineers and even our end customers that we educate on can adjust and use to their advantage. So these are things like increasing the ramp rates, switching between torque and speed mode. We have some really unique features if you're doing traction applications that allow the overall system of the EDU to be able to not clunk, so that your drivability and experience is better. You can also kind of tail off and ramp up the beginning and end of an accelerator push through, and that just gives a lot of customization and ultimately flexibility to the VCU and the vehicle side of things. So it's really capable, really can handle a lot, and obviously putting it through the desert has been kind of the true testament of that. And so in the most recent releases of these units, we have made some upgrades as well. Axial C compliance, you can see, so that meets a lot of automotive standards coming from the autonomous space. You know, the Axial C is what they have on even most of the autonomous systems. So we can fit into many different high technical systems, if you will. So that kind of goes to the automotive grade reliability. And this is a follower unit, so it's one that you'll need a kind of a leader unit to command everything. But with that, you can then daisy chain them to control multiple different motors, multiple different systems, and then all still follow the same CAN command. So really great inverter. I'm really excited to kind of get this out into people's hands and educating them on how to use this a bit more for motorsports and for the EDU application specifically.
Awesome. Yeah. So again, the whole system is kind of designed to function together, and we'll get into kind of the meat of what we're here to talk about, and that is the new EDU for Turntide. And we're really excited about this platform. We've been working on it for about 10 months, I think now. From original design to prototyping to having it actually in several different automotive platforms. Most recently, and we'll talk quite a bit about it, is having it in our race car at King of Hammers, where we raced it in the desert. And really the idea behind this EDU is to have something that our customers can get to market really quickly with. You know, we're consistently and constantly kind of reevaluating it and upgrading it, and really excited to get you guys involved in it as first adopters, and helping us refine the product and get them out there and really, you know, get some real world feedback on what do you guys like about it, what do you not like about it, what are the things we can adjust and change. And this unit, in the form factor that you see on there, kind of a little bit of a vaporware effect. wanted to get a real picture in there, but I didn't have time. But this unit is designed around, a very tried and true differential design. So it utilizes a ring and pinion design. It's based off of the Dana line of gears that we get from a U.S. supplier here. We get those, those are manufactured by Revolution Gear and Axial. So we know that we have a superior gear in the unit. And by doing that and using an off-the-shelf design for the internals, we were able to kind of build it around the backbone and all the engineering and all the testing that's gone into that gearing design, and really push the limits of what that gearing can give us in an EDU. So with our EDU, we start with the E30 size, which is based around a Dana 30 ring gear size. And it can accelerate and grow from there, right? So we start out at about 55 kilowatts with our 250 millimeter motor, all the way up to, the higher end where we are today, which is what we use at King of Hammers, was a 400 kilowatt version. So that's, or 303 kilowatt version, excuse me, about 400 horsepower. So, we've put this together so that you guys can look at, okay, we've got several different motor sizes. We have multiple different platforms you guys can build off of. But we also utilize very dependable, robust gearing on the inside. We are looking at making we do currently have a design for the Dana 44 version, or what we call an E40. So it gives you the capability of transmission of higher torque. And then we do have a roadmap going forward for a 60 size. Gearing ratios on the inside of the EDU, they're going to allow you to get up to, 5.89 is about as deep as we go. And then we go as tall as 3.73. So it gives you some flexibility, which I think is something that the market has been asking for. So it's not a one-shot wonder, right? So it allows you to really define what you want to have in your platform, what you want your product line to look like, and how do we best fit that in to your space and to your application. Does come available with an open differential. It can be a limited slip. We use the Eaton True Track limited slip in it today. So nice, smooth, no cogging, no clicking from the differential. And then it is designed today to have the Eaton E-Locker installed in it, which makes it very, very rare in the EDU world of having the capability of creating a rear wheel drive with a locker, an all-wheel drive system with front and rear lockers. So it's very unique in that capability. All of them are designed for independent suspension right now. So like I said, this can be put in the front of a vehicle, the rear of a vehicle, and it utilizes a 930 CV shaft adapter flange right now, which seems to be the most popular. A lot of our retrofit customers are doing Volkswagens, Porsches, and we'll kind of talk about that in a little bit too. But it allows you a lot of flexibility. Now, if you have a specific application that may require a different style shaft, we'll talk a little bit more about that as well. But it is a very adjustable in what that plug-in shaft can look like. And then today, the units are all machined billet aluminum housings. So this allows for rapid prototyping and some small customization that might work best with your platform. So right now it's kind of designed to go with a base plate mounting system. However, we do know that there are applications where you may want to have a top mount or a side mount or dolly mounts built into your design. So this housing allows us to do these minimal customizations based on your quantity and volume and time to market. But it does allow for very, very rapid prototyping. And, I know coming from King of Hammers, we really did put this thing through a lot more than what I think I ever thought that a Dana 30 could really handle. Going out there with all-wheel drive Can-Ams and Polarises and trying to keep up with them in the desert. Doing some of the climbs over rocks and the whoops and that sort of thing. So we really did put it through quite a bit. I think Snow had had a lot of surprise in his face when he saw what we put that thing through. You know, from its size, it's incredibly torque dense of a unit. So I'll let you guys kind of add some of your thoughts as well.
Well, one of the things that I found at King of the Hammers, man, the vehicle was so small, but it performed so well. And we had the standard, we broke hard parts, we had to do in-field fixes, but the impressive part, we had no issues with the drivetrain. None of the electric stuff, failed us. So that, Dana, design, that E30, it really held up well. And I was really impressed because the tire pressure was so high that it really beat the running gear up, and it all held together. So I thought that was really impressive overall for King of the Hammers.
Yeah, totally agree, Snow. It was beat up on a lot, and as well as covered in so much dust and so much sand. I mean, anyone that's out there knows that you have to wear basically an N95 plus to be able to survive out there more than a day or two. But no, all the seals held up phenomenally. We never had any intrusion of any particles within the unit itself. Getting, even getting in there to change the oil was really, really easy. So the simplicity of the design itself is fantastic. It took a lot. It took a lot of hard discharges from the motor, which obviously put out as much torque as we can. We're really putting those gears and that system through it all. And running, at full sun for multiple hours, trying to go as long as we can. I think we got Jason, 500 miles just around there of testing in about 2 weeks. We're out there, so really, really impressive for how far we got with that, and how much of a beating it took. I mean, that not being the limiting factor is phenomenal news. I think that everyone can kind of rally around.
Yeah. And the other thing that's kind of neat about this design too that we like is that the EDU can actually be oriented forward or reverse facing. So you can put the unit with the differential facing the rear. You can flip it around, put the differential facing toward the interior of the vehicle. So it's not designed to be in one specific location. And it's also designed to sit on an angle. So the one that's in our Sierra platform actually sits with its nose down, with the motor tilted up to fit into the chassis even better. So a lot of the things on the internals of the gearbox, as we worked on the design and the manufacturing of it with our team, excuse me, we added in different features on the internals to allow us to make sure that lubrication held up. And, as you guys know, when you're going out and you're prototyping a platform or you're retrofitting a car, you're always worried about how is it going to hold up? How are the internals put together? And what are the different things that you can do, to really impress a customer and have a successful drive line. And, we've run this unit, as a Dana 30 with, 35-inch tires. Right now it's got 265s on it. So, our speed range is obviously affected by that tire size, but the durability of the unit is designed as such that you could run a larger tire, smaller tire. And then it's also designed to take any of our motor sizes. So, the picture that you see there and the pictures that you'll subsequently see of the race car, they are all with our 400 millimeter motor. However, this unit is designed to take our 300 millimeter and our 250 millimeter motor size. And then when you get into the larger sizes, so if you go to the E40 or the E60, you can get into where you can start double stacking those motors. So recently we ran through a design with a customer that was our E40 with a 300D, which is a double stacked 300 millimeter motor. And that's upwards of 600 horsepower into that differential directly. And really impressive. But what we're after, for you guys as customers, and really from my perspective, being part of the design team and kind of bringing this to fruition, is I wanted to bring something that you guys could have in the market that allows you to be creative, but also know that you're getting something that's durable, and that you can expand on. So what's really exciting about this for a lot of the retrofit market is you can build a base model car, you can build a mid-performance car, and you can build a high-performance car. So it really gives you guys a lot of flexibility to design a platform that's going to be best for your customers. So, and as we progress, we have a lot of things coming that's, we're also really excited about, and that is moving this product line forward, not just creating something today that we feel is going to be sufficient. I wanted to design a product line for you guys that would continue to expand and change and grow. And that's really what this EDU platform is going to be for Turntide. And as we move forward, we have 4 different motor diameters that are going to be available. As you can see here, we've got the 930 stub shafts. You can use an actual plug-in shaft. You don't have to use the 930 adapter. If you're looking for higher amounts of travel, a narrower distance in the center, you can alleviate that stub shaft and just go directly into the differential to allow you to have a longer CV axle shaft. You can get more flexibility out of that design. We're also in the future looking at how do we implement this design into a solid axle design. So not just an independent suspension. So you can get into your smaller vehicles, your, retrofitting Ford Rangers. It's a huge thing here in Texas right now. And even I think out in California, retrofitting your smaller regular cab Toyotas, your regular cab Ford Rangers, all the way up into your full size 68-inch wide track axles for square body pickups, mining vehicles, recreational vehicles, retrofits into the old flat fender Jeep Wrangler or the Willys Jeep. So we're trying to make something for you guys that is 100% very stable, but also it has a lot of customization that you guys can bring into the marketplace. And we really want to work with you guys and continue to do that. So designing things, 32 spline axles, still having the limited slip and the e-locker on the inside. And really the idea is to allow you guys to be creative and really have a product line that you can grow with. So any thoughts, Nathan, Snow?
Well, one of the things I really like is the versatility here, because like you said, most of the time when you start going to the EV conversions, a lot of people use, equipment that's already out there. So basically secondhand equipment. And 90% of the time that's based on IRS. So that independent rear suspension. Well, if you want to build a square body, now with the new Turntide setup, you can keep that live axle setup, which a lot of people, like me, I like to stay, even though I'm going to an electric vehicle, you still keep the truck in its original form factor. And that is a total plus for doing these kind of upgrades. So I like the fact that you got the versatility to do whatever you want.
Yeah, absolutely.
And I think that's the key to growing it. Sorry, Nathan, go ahead.
Yeah, no, I was going to kind of build on that. I mean, the flexibility to have rear-wheel drive, all-wheel drive, four-wheel drive with the e-locker, limited slip, and then also with being able to use 2 different types of motors on 2 different parts of your drivetrain is unreal. I don't think we've really seen that out in the market today, and I'm really excited to see kind of where that goes and who wants to kind of try that out as well, because you're going to be able to have the big power in the rear, and then for that additional either on the front side on a takeoff or a launch, or if you're kind of stuck with the rear wheels in something slippery, I mean, having that front wheel drive as well is going to be really, really cool to see. And may even take us down avenues like regenerative braking, and having it drive rear wheel and then kind of recharging itself. And that's a huge advantage that we haven't really touched on, but one that I think even during the race benefited us a lot in terms of getting us enough range to get to where we did, because of being an electric vehicle, albeit, there were some limitations physically in terms of overall range. I think the amount of power put back into the system, and using these as both propulsion and generators is going to be really, really big for us and for our customers and partners as well.
Yeah, and that's
You know, if I can touch on that real quick, Nate, one of the things that, one of the points you brought up is, as a builder, we've seen multiple, setups. We've seen all-wheel drive, we've seen front-wheel drive, we've seen rear-wheel drive, but none of those were all with the same product. So it's almost like a Frankenstein mix. And I don't think people realize why the new ZR1X, why that car is so fast. It's a hybrid. So it's rear wheel ICE, and the front wheel is assist, and that's electric. And that is one of the fastest cars ever produced. And that's what we're allowing the capability of today with this turntide setup. Now you're branching out into, you can have an electric drive in the front and possibly ICE in the rear.
Yeah. And I think Nathan brought up a good point, and that is too, Snow, is that you can have a system that runs a 400 millimeter, let's just say 400 horsepower rear axle and 125 horsepower up front. So you can have that assist drive. You can even do regenerative braking and do some of those things, with this platform as well. So we're kind of halfway through. So if there's anybody that has any questions before we jump into, some more information, if you've got any questions, throw them in there. Lori, if there's any that we can address, I'll jump in and grab those real quick.
Yeah, let me ask. We've gotten 3 that have come through. Let me ask those for you. The first is, with this right angle drive system, are there no concerns with the high speed output from the motor?
Go ahead, Nathan.
No, with the orientation, I guess I'm thinking the question is related to radial and axial loads on the system itself. And from that perspective, one, our bearings and our shafts are rated to be able to handle some level of axial and radial loading, but then also on how it's mounted with the plate in between, it takes a lot of isolation out of the system and really doesn't take on a ton of force itself. More to be tested. Obviously, this is more of a roadmap type product, but from our perspective, no, there's no concern with how the motor's oriented, which direction it's providing torque, and kind of the forces it's facing in this setup.
One of the things also I want to add to what Nathan just said, I think that question was really based on, most people are familiar with the radial flux motor. They're not familiar with the axial flux because it's so new to the market. Well, an axial flux motor, you could possibly turn 16,000, 18,000 RPM. Well, that's going to blow up any diff, right? But the radial flux, you generally have some sort of reduction box on it, which, bumps your torque, and it reduces that RPM to 8,000 RPM is a high revving V8. Right. So that's what you're actually, reducing this to. So you're essentially taking that RPM, bringing it down to what a normal, like I said, small block Chevy would make, but you get double the torque with the same RPM, and you bolt that right to whatever the EV30 axle or whatever you want. And then so you're still looking at normal performance that people would be accustomed to.
Yeah.
That's a
really great. I'll jump back over here real quick, and without going too far into the engineering and the design of the box, all of the bearings and the componentry that we use in this box are designed based on, my however many years of off-road experience and racing experience. And so we try and use the best bearings we can possibly put into the unit. Most of them are Timken high strength bearings, and making sure that all the radial loads and axial loads are all accounted for. And, whether you're using an X pattern on the bearings, when you put the bearings in there to support the pinion, there's a lot of different things that we've done to make sure that the loads on these, on the bearings and the shafts, are all accounted for. So,
and one last thing I wanted to add on to that before the next question is, I don't know if the audience here necessarily knows, but the weight of these motors range anywhere from about 50 to 200 pounds if you double stack them. But the single stack motors are only, let's say, 40 to 70 pounds. So you're not having as much load literally on that actual shaft, on that axle shaft, as you would with almost any other system. And to Snow's point, you're already reduced speed-wise to where you need to be with already significantly more torque. So it's a really phenomenal system.
Yeah. What's
Y'all
the next
ready
one,
for
Lori?
the next question? There's actually 4 now. We got another one in. There's more than 4,
Okay.
so let's
Yeah,
just
no
keep
worries.
going. Does this inverter use IGBT MOSFETs or SiC MOSFETs?
This one uses IGBT MOSFETs right now. We do have some partner companies. Won't go into too much detail there. You can find it on our website. But for the inverters we create, yeah, IGBTs.
Okay, and the next question is the gear set available as reverse cut, high pinion, and standard cut, low pinion?
So we use the high pinion design right now. That's, we use that design to kind of get the motor up and give us a nice center line, keep the motor in line with the differential. If you use like a low pinion or a mid pinion, the motor would end up hanging down way below the diff. So these are all based around a high pinion. The gear on the inside is we use a 2-pass gear set, so it's a little bit more of a beefy gear. So they're a thick cut gear to allow us to drive them on the drive side and the coast side if we need to. So yeah, but it's designed around the high pinion design.
Okay, y'all ready for me to move to the next one?
Yeah.
Okay. Has a sweet spot differential ratio been found yet, or is it more vehicle dependent?
I think it's we kind of have a 4-band ratio that's in the middle. So if you look at if you took the E40, it would be a 373, a 410, a 513, and a 589. There are different ones in there, and that's going to be driven a lot by your application. So if you're doing high-speed desert racing, kind of like we're doing with the Sierra, we're going to be dropping down from a 456 gear set to a 373 to get more speed out of the car. If you're going to be doing some of the stuff we'll talk about later is really high speed. We're talking about 3-to-1 ratios in 283 gear sets. So I think it's more dependent upon what you're doing with the platform. Let's say you're doing a mid-drive, everyday driver Land Rover Defender. Maybe you want to use a 410 gear set or a 456. So you've got the low end torque. You're not chasing a higher highway speed. So it really is dependent. You're doing an off-road vehicle, like a mining vehicle or something like that. You may want a deeper gear set, like a 589, to give you more regenerative braking and more control as you're driving down into a mine site, but then you've got all the torque that you need to climb out of that mine site. So it really is very dependent upon your application. And that's really what we wanted to focus on with this design, was being able to look at your product and say, okay, how do we fit this in to match what you're building without losing our mind and going 100% bespoke on every single thing. So we want to kind of stay true to the core of what we're designing and not get too far out in the weeds. But we also want to have the versatility there for you. So is that all 4 of them, Lori?
Yeah, since we're about halfway through, let's continue on with the presentation, and we'll ask any others at the end if that works for everybody.
Yeah. So the next thing we're going to talk, and it's a little bit different than the EDU. It's about the whole system. And I'm going to kind of run through this really quick, and then we'll get on to some application stuff. But along with our EDU, we do have a full line of 48 volt products. So we have a 48 volt motor and can be used as a generator or an alternator. We have a 48 volt fan, 48 volt inverters. We have a 48 volt battery and the 48 volt pump. And the reason we bring that up because we don't want to lose sight of there are other applications for these motors in 48 volt and 96 volt applications, some 200 volt applications. Your lower voltage systems like go-karts, motorcycles, UTVs, jet skis, scooters. This whole system could be designed around power generation for a race truck or a mining vehicle, so that we can, build a good, robust system that isn't just focused on one part of the vehicle. So just kind of give you guys a heads up, we do have those. They are integrated together as a system. But if you're looking at, an EDU that you need for a motorcycle project, or a small UTV that's less than 400 volts, we do have the capability of supporting you guys on that.
And real quick, Jason, on those, just for those on the line, those are all on our website. Those are really high performance componentry right there. Each of them individually, they will definitely be able to meet most, if not exceed, a lot of jobs that you're trying to do. But at the same time, that's kind of the market that we're approaching with them, is some of those more premium or high performance applications. So excited to talk about those there in a bit.
Yeah. And that goes, kind of right into some of the applications that we're working with. There's a lot of guys out there looking for new and innovative ways to go to market to add to their product portfolio. The e-bike industry and the electric dirt bike industry is exploding. We're using our 48 volt inverter and our 80 volt inverter in a lot of those applications. The pit bike industry is absolutely going and growing and growing and growing. We want to be supportive of that with our 48 volt motor. Obviously, you can get into bigger bikes with our 250 millimeter motor, and the 300 millimeter motor that we'll be talking about in a little bit. For high speed applications, can be actually put into your electric motor bike and your electric scooter and that sort of thing. So just wanted to bring that up and kind of, give you guys the option to look at those as well. The ones that I think that are probably the most exciting for me, being a hot rod guy and a retrofit guy, is the resto mod world. And this is kind of focused in on the Volkswagen world. However, it fits in the Porsche, it fits in the back of a Mustang, it fits in the front of a Mustang. Can be made to fit into Broncos and Jeeps and pretty much anything out there from the retrofit market. But we kind of focus in on how do we make a product that can be widely adopted to the market. And the Porsche market and the Volkswagen market are two of the hottest growing retrofit bands right now, because they are IF, they're, independent rear suspension. This EDU, at least the E30, is designed to drop directly into a Volkswagen Porsche platform. Basically taking your, 85 horsepower Volkswagen to 911 Porsche speeds at 400 horsepower peak. But really exciting times, I think, for the Volkswagen Porsche industry. And then even further into, pretty much anything that you guys want to build into, because it is a drop-in kind of ready. It's got an 11.75 center distance. That can be machined down and made a little bit tighter if you have a different application. For a retrofit, 930 CV axle stubs. This particular one, the one that is ready to go today, is the E30 140 Gen 5 size 9 400 volt system. And that system is peak 400 horsepower and 1,950 foot-pounds of torque. So I kind of let Snow speak to that a little bit from the retrofit side. That's a lot for a little tiny car.
That is quite a bit. So typically, these little vehicles make 200 to 300 pound-feet of torque. So now you're literally tripling that. And, at current, we have a couple of builds going where we're actually using a turn-tied setup, and it's going to take this little car from, again, 200 horsepower to well over 4 with, massive torque. So I can totally see this application taken off. Is there's a lot of people, we got a lot of inquiries about doing bugs, buses, Carmen Gias, 911s, 912s. So this really opens up the market.
No. And I think it's a good, stable platform. Now, obviously, we're not to that point where, I think it's 100% done. I think there's still some things I want to do to it. We want our customer feedback, but for rapid prototyping and getting into the market, we're ready today to kind of get those things out into the market and let people start really playing with them and having some fun and enjoying the product line. So super excited to kind of see some of the things that you guys bring to the table as far as retrofits and new applications for us to really put this in and push the limits. Because that's really, kind of my idea around this is, we put it in the Sierra car to race at King of Hammers and really push the limits of what that platform can handle. And I'm really excited to see what you guys bring to the table when it comes to retrofitting cars and really doing something exciting. So the next one is UTVs. We've had a lot of CAD models in there. It's a little bit vaporwary, but this is our race car today. This is a Sierra Echo R platform with the kind of this design in the back. It's got the E30 140 millimeter motor in the back of that car, and it will do every bit of 400 horsepower. Fastest speed across the desert we got out of that car with 456s was about 80. We were pushing 80 miles an hour. Yep. I think 76, 78 miles an hour on 35-inch tires with a 20 kilowatt hour pack. So, we were really pushing the limits of what that chassis could handle. But we're really excited to see what you guys bring when it comes to the UTV industry. Retrofitting the Can-Am Razor R or the Pro R. I'd love to build a factory R, a Maverick R, and really kind of push the limits of what a UTV can do. We think there's a real opportunity to bring electrification to the UTV industry. Battery technology's gotten better because we're able to customize the driveline for you guys. We can really kind of combat some of those range anxiety things that come up in the UTV industry. So really excited to see this product kind of get into the UTV industry and really start making a dynamic shift and be competitive in the race industry. There's the go-kart industry, 48 volt and 400 volt, at King of Hammers and some of the other UTV events we've been at lately. We've really seen a lot of the kid UTVs coming out. The 125 millimeter motor would be perfect in a kid's, kind of UTV, a kid's rock crawler buggy, which is something, I'm personally working on for my daughter, the go-kart industry as a whole. So very, very excited to get out there and really talk about some of the new things that we can do with this EDU. The most exciting thing that we're looking forward to for our motors is Turntide's really going after some land speed record attempts this year. We're super excited to be working with Snow, with the guys at Current EV, with Matt, the Welshman, on really seeing how far we can push electrification and EDU technology in the coming year. I'll let Snow kind of talk a little bit about that before we run out of time.
All right. Well, the land speed racing has been in our community, and when I say our community, the EV conversion stuff, it really kicked off about 4 years ago when we went out with Team Vesco, and that's like land speed royalty. So we went out with Vescos and we broke a land speed record, and we pushed an electric vehicle to 358 miles an hour. The two runs combined averaged 358.3 miles an hour, right? So 353.8. So now what we want to do, we expanded on that, and the Welshman and I, the 4 years, we've been going out and we've been land speed racing. We got together as a team with a 246 mile an hour record. Now, the point to telling everybody that is that motor was a bus motor. It was huge. It was heavy. The bike weighed 1,000 pounds with the Welshman on it. That picture right there is me doing 190 miles an hour. So with the turntide motor, we can have the same power in a third of the weight, right? Because we used a radial flux motor. So with this axial flux motor, it's going to allow us to literally blow away kind of our own records. And with the setup, it allows us to branch out into four wheels. With the bottom car, we call it the clown shoe. So we're going out there and we're going to do something that nobody else did. Notice I said we're going to do it. We're not going to try. We're going to do. We're going to come out with a points championship, and that will be the first time in any motorsports that an all-electric team has actually won a points championship. So I'm really excited to work with Turntide, and we got some really big stuff happening this race season.
Yeah, it's going to be exciting. And as we continue, you know, some of the things that we're doing in the EV industry, we're working with diesel hybrid power generation for charging in the motorsports industry. This is a diesel power unit here with this is a 70 kilowatt hour pack. They have a 125 kilowatt hour pack. ANA was our sponsor at King of the Hammers, helping us keep the car charged in the pit. Current LA made this amazing, I think the first in the world I've ever heard of, a level 3 DC to DC remote charger that we used in our remote pit. You can see here in the bottom. So we're just super excited to work with you guys on any and all applications that you guys have, and really push this industry forward and find new ways to get together and make some really exciting things. So we'll open it up for questions and kind of go from there.
Sorry, my computer is lagging just a tad. Yeah, we have several more questions to ask. The next one we have is, which kind of winding concept are you using? Do you use single air coils or directed winded on the stack in a triangle design as one or double layer?
That's a Nathan answer.
Yeah, I was going to say, I think we're going to Nathan on this one.
Yeah.
Can
you repeat the question again? It was cutting out a little bit.
Right there.
Okay, I'm sorry. My computer's been lagging, so if I'm cutting it out, I apologize. Which kind of winding concept are you using? Do you use single air coils or directed winded on the stack in a triangle design as one or a double layer? That's pretty specific.
Got it. Yeah, we don't do the triangle design. I know some of our competitors do. What we do is we have a 3-strand wire that we then wind around a triangle trapezoidal design, but they go front back rather than radially out. And so that's part of our design in terms of how we maximize our torque and efficiency. It's the design that our guys have used for a while now. So that is a distinguisher in the market. But yeah, that we don't follow the same exact design that some of the other axial flux manufacturers do today.
Yeah.
Excellent.
Yes,
Is the cooling an inhibitor medium? If so, can you see this being an acceptable use case for marine drives?
Yeah, so we do our cooling in a little different way, where you look at some of that, like YASA uses an oil medium to cool their stator. Our design is opposite of what YASA does. So we use a glycol system. And for the marine industry, we are working right now on a marine grade version of the motor that would allow for saltwater cooling. So you could cool this with saltwater, allowing it to be used in any marine application. That's an active program that I'm managing today. We're working with several marine companies on powertrain designs that would use saltwater cooling. So it is something that we're looking at today. We do use a higher grade aluminum housing. We've looked at like anodization to allow us to get better lifespan out of the housings when you're using salt water. And then you've got filtration, you've got your electrolysis that happens. So there's a lot of things that go into that, but we are actively researching that. So if you're looking at a marine grade type application, shoot me an email and let's dig into it, because that's a very exciting part of what we're developing with this motor.
Okay, and the next question, The power levels you guys share are above that of most 930 CVs. Is a 934 or 935 stub axle size available with the 40 series axle?
So we do have those axle stub shafts designed. We don't manufacture those ourselves. We get those through a partner, but those designs are completed and available. So we can do different size shafting.
Okay, and this is just a go back to a slide. I did let everyone know again that this is recorded, so you will be able to watch it, but someone got a phone call and wanted to know if you could re-show slide 10, please.
Slide 10.
Good luck. Because I know
That's slide 10.
Okay.
Yeah, I'm not sure how it showed in the webinar, but
yeah, and they'll be able to go back and look at the whole thing. So the next question, what are the max output torque for each of the axle sizes?
So it's going to be dependent upon the motor that we use. So each of the axle designs is designed around the motor that you put on it. So depending on the motor that you apply, whether it's a 300 millimeter, 400 millimeter, 250 millimeter motor, is going to determine how much torque we put. And then once we determine your application, your motor, and the torque requirement that you have, we can then size both the gear set in the housing and the stub shafts that go with it.
Okay. I think we have time for one more question, and this is actually from me. Oh, no, we have a new question. Let me ask this one since I'm not as important at these. The person who asked about the axle sizes and the torque, but mechanically, what is the max torque?
Oh, mechanically, the max torque. Okay. So each of these gear sets are designed with a max torque. Those tend to come from the manufacturer themselves. So like this is a Dana 30. If you go out on the internet and you look at the Dana 30, you're going to find where there are folks that say a Dana can only take 600 foot-pounds of torque. You're going to find some that'll say it can take 1,200 foot-pounds of torque. We're speccing through that right now and going to the limits of what our design will take. The reason I can't give you an axle number is because we have to do destructive testing on these. So you have to basically take them out and you dyno them and you beat them up until you find that limit. We're still in the process of designing and those tests and doing that testing. So that's information that we'll be releasing out in the future of what the max torque range that the differential itself is going to be able to handle. We just haven't gotten to the point where we're ready to release that information yet. But if it's application specific, we can go up in size or down in size depending on your application to make sure that we stay within the designed limitations of the gear set.
And I'd say
I think what you're going to find though is that the gear set is going to be far superior to the axle shaft itself. So if you get into that situation, you're going to be snapping axles before you wreck a diff.
Yeah. And that is one thing, when you get into EDU design, you've got to have a fusible link in there somewhere. Like you've got to have a failure point at some point. So we could over-engineer the shaft, and then you take the gear out. If you engineer the knuckle, the knuckle's going to take the shaft out. If the shaft doesn't fail, it takes the gear out. So we try to design it in, so that we can fit and everything works the right way. But we can look at your specific application and come up with some specs and some designs and look at, do we need to change to chromoly shafts? Do we need to change to a different steel for the stub shaft? So there's a lot of different options that we can bring to bear for specific applications.
Okay, that is all we have time for today. Thanks again to Jason, Snow, and Nathan for joining us and for the excellent conversation. Attendees, thank you for joining us as well for this webinar. It will be available on demand in about 48 hours. We hope you'll join us in March for the webinar tech tour of the Axial Flux EDU. That link is in the chat. And have a great week. Thanks again for joining us.
Thank you, everyone.
All right. Thanks, Lori. Thanks, everybody.
Take care.